Hello, everybody. Today I will talk about a special question about imaginary number, the addition of a series with imaginary numbers. The question is, what is the answer 1 plus I squared plus I cubed and so on, power 4, power 5, until power 67. What is the sum of this sum? What is the answer? We look at each term separately. 1 can be written as I to the power 0. Anything to the power 0 is 1. I is defined as square root -1. I square is square root -1 times square root -1, and the answer is -1. I squared is -1. I cubed is square root -1 times square root -1 times square root -1. But the first two square root -1 multiply to get -1. So this is negative square root -1. So which is -I? What is I to the power 4? It's I squared times I squared. But I squared is -1. So this is -1 times -1. This is 1. I to the power 5, we can write as I to the power 4 times I, but I to the power 4 is 1. Therefore, this is I. Similarly, we can see that I to the power 6 is I to the power 4 times I square, and this is just I square, so it is -1. I to the power 7 is I to the power 4 times I to the power 3, so this part is 1, therefore this is I to the power 3, which is just -I. Then the next one, I to the power 8, is I to the power 4 times I to the power 4. It is 1 times 1 and is equal to 1. So let's put the answers here below this line. This thing, 1 plus I squared and so on, is 1 plus I minus 1, because I squared is -1. Then this is I cubed. I cubed is minus I. So I see 1 I, -1, -I, and then it repeats the pattern. The next is 1 plus I minus I, -1 minus I, and so on. So it repeats the pattern every 4, you see, from 1 to -I, you repeat it. From 1 to -I, you repeat. Every 4 you repeat. Look at the power. This power is 0. This power is 1. This power is 2. -1 is here. Power is 2. So power 0, 1, 2, 3. And then power 5, power 4, 5, 6, 7. So every 4 is a basic pattern. Yes. All right. But look at this. What is the sum of these four terms? 1 minus 1 is 0. Plus I minus I is again 0. So every 4, if you add them up, it's 0. Every 4, you add them up, it's 0. Then we can work on this thing. Let's write a few more terms after 67. So I want to stop here, but let's look at what's after this term. So 68, 69, and so on. Look, this one is power 4. Power 4 is 1 times 4. This one is power 8, which is 2 times 4. So you see the pattern that if the power is a multiple of 4, the answer is 1. When n is 8, the value is 1. So when n value is a multiple of 4, the value of that term is 1. Now let's look at the next term after power 67. That's 68. 68 is a multiple of 4. 68 is 17 times 4. It is a multiple of 4. Therefore, the value of this is 1. What is the value before 1? Before 1 is negative I. So I to the power 67 should be negative I. Then if you go one more before that, it should be negative 1. So this is negative 1. And then go back, so it should be I and should be 1. So this I to the power 67 is the end of the 4-number pattern. You see, negative I. So it's the end of the 4 as a group. But we know these 4 as a group, the sum is 0. So up to here, everything is 0. Therefore, what is the answer here? It's a big 0. That's the answer. So the answer to this series of imaginary numbers is just 0. So you get the answer by looking at the pattern. And you discover that every 4 terms, you repeat itself. And that's the answer. The number is 0. Okay, that's this question. And that's for today. I'll see you next time. Goodbye.